Hello everyone, welcome back again in today's lesson video. So today we're going to be looking at calculations under Newton's law of universal gravitation. Okay, we're going to be looking at further calculations. Okay, yes, nothing much. Please don't forget to subscribe. If you are new to the channel, please subscribe right now. Subscribe. Thank you so much. Yeah, let's get into today's lesson video. Okay, so this basically means that, just to remind you guys, so every point mass, okay, attracts every other point mass. Okay, this mass is attracting this mass, and also this mass attracting this mass by a force, by this force, okay, that you are required to calculate here, okay, in this formula, directed along the line connecting the two. So this force is directed along the line is connecting the two, and mind you, the force starts from there, from the center of an object. Okay, from those two objects, each force starts from the center of those two objects, as I showed you in the previous video. So I'm just going to show you again today, but mostly on the interaction of the object as well as the earth surface, the earth, I can say. So these force, or I can say this force, is proportional to the product of masses. Okay, so this force, that force is proportional to, or I can say is direct proportional to the product of these masses. Okay, to the product of these masses, they are multiplying. Okay, yes, and this force, okay, is inversely proportional to what? To the square of the distance between these two objects. Okay, yes, and that's how we received our formula. Okay, yes, our gravitational formula. So again, guys, so that I don't forget to tell you this vital stuff, this formula is also the same as this formula, because this is gravitational formula. So this formula is the same as this formula. Okay, Fg, so that's Fg again. Fg is equals to mg. Okay, yes, the gravitational formula. Okay, yes, this is determining the gravitational force as well as the weight. Okay, so if ever this formula is the same as this formula, okay, so one thing we should know, okay, right now, is that when we, okay, so we also have the gravitational acceleration, which is a different stuff, or which is a different concept to the gravitational force. So meaning that the gravitational acceleration is different from the gravitational force, because most of you guys like to confuse the two. So right now, so the gravitational acceleration is the speed whereby, okay, or is the sudden acceleration whereby the earth is accelerating downwards the object, okay, at 9.8 meters per second squared. Okay, yes, that's acceleration. So the gravitational force is the force that is being applied by earth on the objects, okay, so that the objects can move towards earth or to the earth's surface. I hope you get me. So we also have the gravitational acceleration. This is the gravitational acceleration. This is the gravitational acceleration, as you know. So also have the gravitational acceleration formula. So the gravitational acceleration formula is derived from where? It's derived from this formula of the gravitational force. So this formula F, so this is like Fg, which is equals to the gravitational constant m1 m2 over d squared. Okay, look, so I said to you, today we're going to be sticking more on the objects, between the earth and the objects. Yes, the gravitational force between the objects and the earth. Okay, look, so let's make an example and say, let me just move this. Okay, so sorry, let me say, for example, we have earth here. Okay, let's say we have earth. This earth is round like a ball. Okay, so this is earth. So one of the things you should know, the radius of the earth. Okay, yes, just before deriving the formula of the gravitational acceleration. Okay, yes, so we have this is the center. Okay, yes, the center of the earth. So if ever, let's say you, okay, you student, you are here. Okay, let's say you are here, and yeah, let's say you are here. Okay, let me explain this effectively. Look, this and this is the same thing, but this, as you can see, this is the formula that is equal to the gravitational force, as well as this one is the formula that is equal to the gravitational force. So when I'm saying this formula is equal to this formula, okay, this is whereby in this one the difference is only whereby this one, the object or the person is on the space. We use this one. So this one is only applied to the objects that are in contact with the earth's surface. Okay, yes, like in this instance, this one here, this person here is on the earth's surface. But if ever, yes, meaning that in order to calculate the weight or the gravitational force acting in this particular person here or in this particular mass, we have to use either, you have to choose either this one or this formula. Okay, yes. So but if ever, let's say this person is on the space, is right here on the space, is flying here, okay, is on the space, okay, is on the space right now. You can see that this person is not in contact with the earth's surface. So which formula are we going to use? Only this one, because this one only applies when the person or the object is in the contact with the earth's surface. Okay, let's move right now. Okay, so okay, so let's say this is the center of the earth, and just don't mind this person, okay, this one on the space. Let's say this one, okay, this is the radius to the center. So this must be the center of the person. Yes, something that there's not much difference, guys. So the center might be just the earth's surface, okay, yes, of the person, same thing. Okay, so the radius of the earth is always constant, okay, it's always the same thing, and even in your question paper they are going to give you the radius of the earth. So this becomes the radius of the earth. Let me just say r, the radius of the earth is equal to the radius of the earth is equal to, so this is the radius of the earth. We just say capital letter r. So it's RE is equal to 6,38 multiplied by 10 to the power of 6 meters. So this is the radius of the earth, the line drawn from the center to the circumference, or the line that is drawn from the center to the other object that is in contact with the earth. Okay, yeah. So what's the other thing that I should tell you is the mass of the earth. Okay, so the mass of the earth, let me just say M-E will be equal to this mass of the earth is equal to 5,98 multiplied by 10 to the power of 24 kgs, okay, yes. And our mass units are already solved, or already converted to kilogram. Okay, yes. Okay, look, that's how it goes. So you have to know this by your head, okay, the radius of the earth as well as so that you're not confused. But they are going to give you during examinations in your question paper, in the last page, one of the last pages, that have information about the formula, etc., in physical science paper 1. Okay, that's how it goes. Okay, so let's move to this side right now. Okay, before moving to this side, okay, let's say, okay, you want to calculate the Okay, so let's derive the gravitational acceleration formula. Okay, yes. So this person, okay, let's say this person is which mass? We'll say it's m2. It's our m2, and this the m1 is the is the gravitation is the mass of the earth. Yes, m1. So let's say f g is equals to gravitational constant m of the earth and the mass of that person there. Let's say this is a human. Okay, let's say a person. Okay, of the person over d squared. What's the radius? Okay, the radius is 6,38 multiplied by 10 to the power of 6 meters, which is our RE. Okay, yes, and the radius of the earth. Okay, yes, that's how it goes, squared. Okay, that must be squared. Okay, and mind you that this D is also the same thing as R. Okay, yes, that's also the same thing as R. This is the distance, okay, the center of squared distance from the certain object. Okay, yes, so this is from the center of the earth, because earth is round, so it's R. Okay, it's a radius, so it becomes a radius. So the same thing, you can just also write D squared. Okay, yes. Okay, let me not change it. Let's say this is D, so that you don't okay, no problem. Let's just say R. Okay, so this is equal to what? Fg, you know that Fg is equals to mg, which is equals to weight. So is equals to mg. So mg is equals to this gravitational constant, mass of the earth multiplied by the mass of the person over r e squared. Okay, yes. So as you can see, we want to calculate the gravitational force or the weight of that person there. Okay, yes. So this must be the mass of that person multiplied by the gravitational acceleration, which is equal to 9.8. Okay, so as you can see, this mp, the mass of the person, cancels the mass of the person this side. Okay, they're the same thing. So and therefore our gravitational acceleration will be equals to gravitational constant, the mass of the earth, over r e squared or rd squared. Okay, that's how it goes. So this becomes our formula for the gravitational acceleration. Okay, I'm trying to be very slow in explaining each and every concept here, guys, so that you can be with me. Okay, don't get lost, please. And if you have any kind of questions, please comment on the do comment on the comment section below. Okay, yeah. You can pose any kind of questions. You can request any kind of examples as well as lesson contents. Okay, yes. So and please don't forget to subscribe, just to remind you. Okay, so right now, this is our gravitational acceleration formula. This is how it's derived. Okay, I hope you can see. Okay, right now let's make an example. Okay, when calculating the mass of this person. Okay, the mass of this person. So let's say the mass of this person is let me redraw here. Let's say let me redraw it here. Okay, so this is the earth, so this is the person in the surface, or in the earth surface, or on the ground. Okay, and their mass, let's give their mass. Their mass is let's say 50 kg. Say 50 kgs. This person at 50 kg, that's their mass. Okay, that's their mass. Okay, the mass of the person. And okay, so right now the question says okay, so let's say the question says let's calculate the gravitational pull between the earth and the man or the person with a mass of 50 kg. So if this man is on the earth's surface, let's calculate if this man is on the earth's surface. Okay, yes, let's just go up a little bit so that you can be able to. Okay, so let's calculate if this man is on the earth's surface. So you know that this is our formula. F is equals to gravitational constant, the product of the masses over d squared. Okay, over d squared. Okay, look, right now we're speaking about, again, just to remind you, about objects that are in contact with the earth's surface or in the earth's surface. Okay, yes, so this object here, this person is in contact with the earth's surface. So when substituting our m1, you know that this is going to be this is going to be the mass of the earth. This will be equal to and m2 will be the mass of the person. So the distance will be the radius from the center of the earth to the person. Okay, so our gravitational constant will be, you know that our gravitational constant is 6,67 multiplied by 10 to the power of negative 11. Okay, so it's 6,67 multiplied by 10 to the power of negative 11. What's our m1? Our m1 is the earth. Okay, yes, is the mass of the earth. What's the mass of the earth? Mass of the earth is, you know, I gave you the mass of the earth. Okay, I hope you can see that. The mass of the earth is 5,98 multiplied by 10 to the power of 24 kgs. Okay, so that's the mass of the earth. Mass of the earth is equal to, so sorry, this must be multiplied. Okay, so sorry, 5,98 multiplied by 10 to the power of 24 multiplied by what? Okay, bracket. Okay, bracket. What's the mass of that person? Is 50 kg over, what's d squared? D squared, the radius of the earth. Okay, the distance between the two, the distance like this, the distance from the two, from the center, from their centers to the center of the person. So this is going to be the radius of the earth. So this is r, the radius of the earth. What's the radius of the earth? It's, you know, the radius of the earth, it's 6,38 multiplied by 10 to the power of 6. Okay, and that's how it goes. Yeah, so radius of the earth, it's 6,38 multiplied by 10 to the power of 6 squared. Okay, squared. Okay, I hope you with me. Okay, so this is equals to, let's punch in that in our calculators. Let's press that in our calculators. So 6,67 multiplied by 10 to the power of negative 11 multiplied by the fraction 5,98 multiplied by 10 to the power of 24 to the power of 24. Open another bracket, that's 50, or close bracket, go down, that's going to be 6,38 multiplied by 10 to the power of 6. Be careful when pressing our calculators, guys. Squared. Okay, 6,38 multiplied by 10 over 6. Okay, that's equals to 4.90 multiplied by 10 to the power of 2. That's our force there. That's our force, 4.90 multiplied by 10 to the power of 2 newtons. And that's how it goes. Okay, so that's our answer. Yeah. I hope you pressed well on the calculators. Please also use your calculators, guys, so that you can be able to also apply in terms of calculations and. Okay, so this will be the same thing as I told you that let me just go down, that FG, this FG is equals to mg, so this is equals to the very same thing because it's in contact with the earth surface. So it's going to be 50 multiplied by 9,8, which is equals to what? 50 multiplied by 9,8 is equals to the very same thing. Okay, if ever your calculator is in scientific mode, it's going to give you the very same answer, 4,90 multiplied by 10 to the power of 2, and that's how it goes. Okay, that's how it goes. So yeah, give us the very same thing because the object is in the contact with the earth surface, or the person is in the contact with the earth surface, and that's how it goes, guys. Very easy like that. If ever you have any question again or any kind of a comment, please comment on the comment section below. Yeah, so that was our very first calculation. So right now, let's say this person, okay, is at 8,000 meters away from the earth surface. So that person is, okay, let's move this side, so sorry. Okay, just give me a few seconds, guys, so that you can arrange my board in okay, yes. Okay, look right now, let's say, okay, I'm just going to be very slow, guys. I'm just going to be very slow so that you don't miss anything, okay, in this lesson. Let's say right now the person is 8,000 meters away from the earth's surface. So this is the person. That person is 8,000 meters away. Okay, that person who is 50 kg, the mass, okay, is 8,000 away from the earth's surface, or from the earth. So the distance from here to here is 8,000 meters, okay? Yes, 8,000 meters away, okay, from the earth's surface. So right now, let's calculate the gravitational pull, okay, between that person and the earth. Okay, so you know that the Newton's law of universal gravity says that these two masses are attracting each other, okay, yes, by a certain amount of gravitational force, okay, yes, with the between, so the distance must be squared, okay, yes, between them. So my fundamental point in this statement is that you should know that this earth is pulling this object backwards or pulling it towards itself. Yes, that's how it goes. So right now, you know that the distance from the earth surface to the person who's on the space is 8,000 meters away. Okay, so right now let's calculate. So you know that when calculating this one, we are going to only use the Newton's law of universal gravitation formula, not Fg is equals to mg, not this one. We're definitely not going to use this one. Not this one, no, because this one is only applicable to the objects that are in contact with the mass, or the masses that are in contact with the earth's surface. Okay, yes, so this one is only applicable to the masses that are in contact with the earth's surface. But now this one is away from the earth's surface, meaning that we're going to use this one. Fg is equals to the gravitational constant m1, the products of the masses over d squared. Okay, so let's calculate, let's solve a problem. So this will be equals to what? This will be equals to okay, so 6,67, the gravitational constant is always the same, multiply by 10 to the power of negative 11. So m1, that's going to be the mass of the earth. m1, the mass of the earth. What's the mass of the earth, guys? The mass of the earth is always constant, you know, it's 5,98 multiplied by 10 to the power of 24. Okay, yes, it's the mass of the earth. What's the mass of that person? The mass of that person is 50 kg. Okay, yes, over d squared. What's d squared? D squared is the distance between them. Okay, and mind you that the distance, okay, must be from the center of each and every object between the two objects. Okay, yes, so distance from the center of this person to the earth's surface is 8,000 meters. So meaning that the center of the earth, okay, must start from the center of the earth, and the center of the earth must be from the radius, meaning that we're going to add our radius. Okay, yes, so this is going to be the radius of the earth, or DE, or this is going to be the radius of the earth, or DE. Very same thing, guys. Distance, radius is the distance from the center of the circle to the circumference, or to the end of the earth. Okay, yeah. So we're going to add this the radius. We're going to add the radius of the earth plus the distance from the earth's surface to the person, which is 8,000. Okay, yes, here. So so this is going to be what's the radius? The radius of the earth is I told you guys, it's 6,38 multiplied by 10 to the power of 6 plus what? Plus 8,000. Plus 8,000 squared. Okay, let's punch in this in our calculators and get the answer. Mind you guys, please also press on our calculator, so that, but at least if ever maybe I made a mistake with my calculator, because I'm full of mistakes, at least if I made a mistake, that's not the issue, because at least if ever you are able to apply and understand the calculations. Okay, yes, multiply, so 6,67 multiplied by 10 to the power of negative 11, multiply by this, open brackets, so 5,98 multiply by 10 to the power of 24, 50, so sorry, 50, so I have a 50, 6,38 radius of the earth multiplied by 10 to the power of 6. Okay, plus 8,000 meters squared. Okay, yes, plus 800 close bracket squared, that is equal to 4 comma, and my calculator gives me, I don't know yours, 4.89 multiplied by 10 to the power of 2, and that's it, and that's our force that is being applied, or the force of pulling by the earth to that person. Okay, so earth is pulling that person by 4.89 multiplied by 10 squared newtons. Okay, please don't forget the the units, guys, for that force of the pull. Okay, yes. I hope I punched my calculator in a correct way. Yeah, that's how it goes. That's how it goes, guys. Thank you so much. Okay, so let's move now to other calculations. Okay, so our next example says a lift with the mass of 250 kgs is initially at the rest on the ground floor of a tall building. Okay, yeah. So passengers with an unknown total mass climb into the lift. The lift accelerates upwards at the speed of 1.6 meters per second squared. The cable supporting the lift exerts a constant upward force of 7,700 newtons. Okay, so we have this instance here. We have our lift. Okay, so we have our lift. This is our lift. Just going to draw here. Okay, let me draw here on that side. Yeah, let me just draw here. So we have our lift. This is the lift with a mass of 250 kgs. 250 kgs. This is the mass of this lift. The passengers are unknown, so we have passengers here. Let me just say passengers. Passengers. Okay, yes, not two or even two or more passengers. Okay, yes. So the lift accelerates upwards. So this lift accelerates upwards. Okay, by what? By 1.6 meters per second squared. Okay. The cable, this cable that is pulling up this lift exerts a constant force of 7,700 newtons. Okay, yes. So that's how it goes. Hope you can see. Yes, all of you can see. So the very first thing says right now, draw a free body diagram indicating all forces acting on the lift. Yeah. So okay, so let's just say like this. So sorry. Okay, so let's say for these are the answers. So number one, for answering them, so draw a free body diagram. So this is going to go to our free body diagram. Make it sure that the dot, okay, the dot is quite bigger because you might have two forces that are on the same direction. So draw a body diagram indicating all forces acting on the lift as it accelerates upwards. So we have the upward force that is pulling the lift upwards and which favors the motion. So the upward force, let's say it's a tension force, or it's a, okay, so let's say it's a applied force, is equals to 7,700 newtons upward force. And you can see that we have the lift right now. Okay, we have the lift. The lift is 250 kgs, and the passengers, okay, the mass of these passengers, the mass is m, is unknown. Okay, so meaning that this is the of the lift, okay, the gravitational force acting on the lift, and this is the gravitational force that is acting on the passengers. Okay, gravitational force that is acting on the passengers. Okay, yes. So this ft plus this ft, we have ft. Okay, same thing. Okay, yes, but I just wanted to make sure that you can clearly see everything. Okay, yes. So you have two gravitational forces, either on the person or on people that are inside, or passengers inside, as well as on the lift. Okay, so right now the second question says, what is the maximum mass m of the passengers the lift can carry in order to achieve a constant force upon acceleration of 1.6 meters per second squared? Okay, this is very quite easy, guys. Okay, let's calculate it on this side. Okay, yes. So what is the mass m of the passengers the lift can carry in order to achieve a constant acceleration, upward acceleration of the of the 1.6 meters per second, or of 1.6 meters per second squared. Okay, so number 2, let's answer number 2 on that side. Number 2. Okay, everyone can see that side. So answering number 2, just say like this. This is number 2. Okay, the question the question is basically asking us what will be the mass, or the average, the maximum mass of the passengers that must be inside the lift, so that the lift can be able to pull, okay, or to move, or to pull the lift upwards. Okay, yes. So meaning that if ever the lift is full of passengers which are above the force, okay, the opposing force, the lift will not be able to, or the cable can't able to, because the force, the maximum force that the cable has is 7,700 newtons. So if ever the opposing force is more than those forces that are caused by the masses of the passengers, the lift can't accelerate upwards or move upwards. I hope you get me, guys. So right now, you know that the net force is equal to ma. So what all the forces acting on that lift, you can see in our free body diagram. The net force acting on that lift, it's the force that is applied minus, opposed by the 2 gravitational forces, okay, minus those 2 gravitational forces, gravitational force of the lift and gravitational force acting on the people inside the lift, or passengers. And the mass, what's the mass of the lift? The mass is unknown. Oh, the mass of the lift is 250 kg. So the mass of the lift is 250. Okay, so 250 of the lift plus the mass of the people inside, okay, of the passengers, multiply by what? The acceleration of the lift upwards must be 1.6 meters per second. Okay, yes. So sorry for writing meters per second. So sorry. Sorry for daily work. So sorry, guys. So FA, so 7,700 newtons minus, what's our FG for the lift? This is FG for the lift, and this is FG for the passengers. Okay, so FG for the lift, it's going to be, let's go and calculate this way. So FG for the lift, hope everyone can see here. So FG for the lift, let's calculate it here, this side. So FG for the lift will be equal to mg. So mass of the lift multiplied by gravitational acceleration. What's the mass of the lift? Mass of the lift is 250 multiplied by 9.8 meters per second is equal to what? Let's press on calculators. So 250 multiplied by 9.8 is equal to mode 8 to 2000. So 2,450 newtons. So that's the gravitational force acting on the lift. Okay, so let's go write it down. 2,450 newtons plus, what's the gravitational force acting on the passengers? Let's calculate it. So the gravitational force acting on the passengers will be equal to passengers, okay, will be equal to mg, mass of the passengers multiplied by the gravity. So what's the mass of the passengers? The mass of the passengers is m multiplied by 9.8. Gravitational acceleration is equal to 9.8 m plus 9.8 m. Okay, close that. So let's multiply 250 multiplied by 1.6. 250 multiplied by 1.6 would be equal to 400. Okay, that's equal to 400. So m multiplied by 1.6, m multiplied by 1.6 is 1.6 m, right? Yes, plus 1.6 m. That's how it goes. Okay, yeah. Okay, so this is 7,700 minus 2,450 minus 9.8 meters, because this sign is multiplying this sign, that's why it's changed. 400 plus 1.6 m. Okay, so right now, so press on calculator. 7,700 minus this, so 7,700 minus 2,450 is equals to 5,250. So we have 5,250. So this 400 is going to come this side, it's going to minus 400. Minus 400 is equal to, this is going to go that side, so it's going to be 9.8 meters plus 1.6. So sorry, not meters, sorry, mass, m. Yes, 9.8 m plus 1.6 m. So 5,250 minus 400, that's equal to 4,850. So 4,850 is equals to 9.8 plus 1.6. 9.8 plus 1.6 is equals to 11.4 m. 11.4 m, which is the mass. So let's go and find the mass. Divide by this side, divide this side. So this cancels this, we left with m, and therefore our m is equal to what? So 4,850 divided by 11.4, that gives us 425.44. Let's round that off. So the mass will be this kilograms. So this will be the maximum mass that the passengers must be on the lift, so that the lift can be able to pull that or so that the rope or the cable that is pulling the lift apart, so that it can be able to move the lift or to accelerate the lift by 1.6 meters per second upwards. I hope you get it, guys. Yes, so these are the calculations. I try to be very slow as much as possible. So let's move to the last example for a day right now, which is very important. And this was the question that was taken from the exam, or the past exam. Okay, yes. So the question says state Newton's law of universal gravitation. The very first question. Okay, so okay, let me just write down for you. Okay, that's going to be number one for answers. So these are answers. So these are answers underneath. Okay, so Newton's law of universal gravitation states that, so it states that, okay, every point mass attracts every point mass by a force directed along a line connecting the two. Connecting the two So this force, this force is directly proportional. You can say it's proportional to the, so this force is proportional to the product of the masses, the masses, and inversely proportional inversely proportional to the square of the distance between them. So that's how it goes. So you know that Newton's law of universal gravitation states that every point mass attracts every point mass by a force directed along a line connecting the two. This force is proportional to the product of the masses, and it is proportional to the square of the distance between them. Okay, yes. So, and that's how it goes, you know. This is this, and the distance must start from the center. The distance will be squared. Okay, yes, and that's how it goes, guys. Very straightforward, and this brings us to the formula of universal gravitation that I introduced you to. Okay, so number 2 says, okay, so since number 2 is calculations, let's do it on that side. So number 2 says the mass of the sun is 330,000 times greater than that of the earth. The distance between the centers of the sun and the earth is 1.38 multiplied by 10 to the power of 9 meters. Calculate the gravitational force that the sun exerts on the earth. So meaning that the sun is exerting a certain amount of gravitational force to the earth. So let's calculate that gravitational force. So let's just take this instance and say, okay, look, in this instance, number 3, meaning that at number 3, okay, let's just say here, just try a line. Okay, let's say number 3 here. So for number 3, let's calculate. Okay, so F, you know that F is equal to gravitational constant. This is M1, which is going to be our earth, and M2 is going to be the sun, mass of the sun, over d squared. Okay, yes, over d squared. Okay, so mind you, we're looking for the force. Okay, yes. Okay, so again, just to remind you that it says that, okay, it says that we have the sun, so we have the earth, meaning that we have the earth and we have the sun. So sorry, and we have the sun, meaning that the sun is very bigger than the earth, because as you saw that they said, the sun is 330,000 times greater than. That's very, very huge. Okay, yes. So this is the radius from the 2. Okay, yes. So this is distance between the 2. So the distance between the 2 is 1.38 multiplied by 10 to the power of 9. That's how it goes. Okay. So this is the sun, and this is the earth. This is the earth. Yes. Okay, so let's calculate and let's solve a problem. Okay, so our force will be equal to 6.67 multiplied by 10 to the power of negative 11, our gravitational constant. What's the mass one? The mass one must be the earth. So M1 must be the earth. What's the mass of the earth? Mind you guys, the mass of the earth is 5, 98 multiply by 10 to the power of 24, right? Yeah. KV, okay, open brackets. What's the mass of the sun? The mass, oh, I don't think I'll have a space here, guys. Okay, let me just cancel that. Okay, so let's say 6,67 multiplied by 10 to the power of negative 11. What's the mass of the sun? It's 5,98 multiplied by 10 to the power of 24. So this is it. So the mass of the sun is 330 times greater than the of the earth. Okay, yes. So we're going to multiply 330 multiply by this again. Okay, 330,000 multiply by 5,98 multiply by 10 to the power of 24 over d squared. So the distance is 1,38 multiply by 10 to the power of 9. So that equals to, punch that in your calculators, guys. Let's punch that in our calculators. 6,67 multiply by 10 to the power of negative 11 multiply by 5,98 multiply by 330,000 multiply by 5,98 multiply by 10 to the power of 24 divide by 1,38 multiplied by 10 to the power of 9 to the power of 2. So to the power of 2, so sorry, to the power of 2. Then our answer is 4,13 multiplied by 10 to the power of 26 newtons. So that's our answer. That's our answer there. Let's move quickly to question 3. So just to re-explain this, guys. So the mass of the sun is 330,000 meters, or 330 times the mass of the earth. Let me repeat, the mass of the sun is 330,000 times the mass of the earth. So that's why I multiply the mass of the earth by 330 by 330,000. Okay, yes. Okay, yes. That was number 2. So sorry, I'm tired right now. So number 3, how will the gravitational force that the earth exerts on the sun compared to the answer question 2? So how will the gravitational force that the earth exerts on the sun? So mind you that they are saying that in the very first instance, this whereby there was a certain amount of the force that was being exerted by the sun on the earth. Okay, so that was 4,13 multiplied by 10 to the power of 26 newtons. So the difference right now, or the question right now, says how will the gravitational force that the earth exerts on the sun compared to question 2. So the sun will also exert a certain equal amount of the force, or the certain amount of the force with the equal magnitude, but in the opposite direction to the sun. Okay, yes, which is also aligned to Newton's third law, if you still remember. Okay, yes. So The answer is equal to. So write only greater than, less than, or equal to, give a reason. So the reason is, you can just say Newton's third law, or you can say okay, let's say Newton's third law. Newton's third law, and you can just say if body A exerts a certain amount of force on body B, then body B exerts a certain equal amount of magnitude but in the or in an opposite direction. That's how it goes. So that's Newton's third law. So that's why it's equals to. So as the sun has exerted the force of 4,13 multiplied by 10 to the power of 26 newtons to the earth will also exert that said amount of force to the sun, and that obeys Newton's third law, which says that if body A exerts a certain amount of force on body B, then body B exerts a certain equal amount of magnitude to body A. Yes, to body A. So sorry. So to body A. I hope you know this, guys. I've made videos on Newton's first law, second law, as well as third law mostly, because we talk about third law. So but in an opposite direction. So in an opposite direction, so this obeys Newton's third law, and that's how it goes, guys. And that's the end of our lesson video for a day. Never thought this is going to be very, very long like this, guys, but I tried to be very slow, explaining each and every concept, and I fully believe that I was effective in this lesson video. Yeah, please don't forget to subscribe right now. Subscribe. Thank you so much. See you in the next following video. Have a great day. Cheers.